So for testing purposes, we're going to use a Hampton machine to simulate our ECU load. So we've got 120 volts flowing out of here through the solid state relay, and to close the gate on the solid state relay, we have 5-volt input coming in from this source, and that is not being provided. It will close and electricity will not flow through. But once the electricity flows through, it goes through our Hampton machine load right here, and this is roughly 9.79 plus 9.74 J for the impedance on the actual Hampton machine. The ECU load is actually roughly 8 plus 8.26 J. This is as close as we can get with the provided impedance values and capabilities of the Hampton machine. We had to utilize all three 1 kVA inductance loads to try to get as close as we could. So electricity flows through the load, and it's measured up here. We should be getting roughly 120 volts RMS, and we're getting just over 114. We should be getting about 10 amps, and we're getting just over 9. We should have about 800 watts of real power, and we're very, very close to that. Our power factor should be just over 0.7. We've got negative 0.76 because of the inductance loads, and we should be looking at about 60 hertz for the frequency. Now, we've got our heat sink attached to our solid state relay to dissipate heat, and with this test bed, we can test the temperature dissipated from the actual relay and use a heat gun to monitor the changes in temperature. And using that, we can attach our HS301 heatsink once it comes in the mail, and we can see and make sure and verify that the heatsink dissipates enough heat to perform at the right specifications. And we can also put this inside of our enclosure when we're packaging the overall finished product, and we can also monitor the heat output and make sure that it does not overheat with inside the enclosure.